Alright, hello and welcome back. I'm going to go through problem number 8 from a Physics C Mechanics multiple choice test. Let me bring you a little bit closer so we can read this problem. A ball of mass m is dropped from rest from a height h and collides elastically with the floor, rebounding to its original height. What is the magnitude of the average force applied by the floor on the ball during the time the ball is in contact with the floor? So, oops, I accidentally wrote some of the answers down before we started the video, so let's just ignore that. We're going to look at our answers. So, A, 0, B, mg, C, 2 mg, 4, or D, 4 mg, and E says the force cannot be determined without knowing the length of time that the ball is in contact with the floor. So, the first concept at play here is Newton's third law. This is a pretty essential law in physics. It says that whenever a force is applied on one object, the force that the object that force is applied to exerts an opposite but equal force on the first object. So opposite meaning in opposite direction, but equal meaning of the same magnitude. So in this case, the example here, the ball is going to exert a force on the floor because it's going to fall and hit the floor. And in doing so, according to Newton's third law, the floor is going to exert an opposite but equal force on the ball. So we're going to draw a free body diagram. That's our next step right here, with the ball as the mass falling down. The only force on the ball is the force of gravity, mass times gravity, pointing downwards. There's no other forces. So now that we've done that, we know force is equal to mass times acceleration. Newton's second law. This dude Newton really knows what he's doing. He's got a lot of helpful ideas. So that acceleration in this case is the force of gravity. Force equals mass times gravity. And then, all right, we're caught up. Whew. That was a bummer. All right. So yeah, we know the force that the ball is applying on the floor is this force, mass times gravity, because that's the only force in the picture. So according to Newton's third law, the floor is going to exert that same force upwards on the ball. That leads us to our answer B. But let's just continue looking at this with like some other examples and talk about what a force means, or what Newton's third law really means when it says opposite but equal forces. So, for example, if we got the floor here and we've got Jimmy John right here, let's give him a little hat, standing on the floor. He's exerting a force on the floor, right? His weight, so mass times gravity, and then the floor exerts the same in magnitude, the same magnitude of force, but in the opposite direction, up versus down, on Jimmy John. So you can say, let's just call him J, and we'll call the floor. So the force of Jimmy John on the floor. This is a notation. The first subscript is what's applying the force to the second subscript. So the force of Jimmy John, shown by J, on floor, which I've represented as F, is equal but opposite to the force that the floor exerts on Jimmy John. So here's another example. I hope that clears things up a little bit regarding what Newton's third law is. But yeah, this problem can trip you up a little bit by saying during the time the ball is in contact with the floor, but in reality it's virtually instantaneous. I mean E looks like an attractive answer at first, saying it cannot be determined, because it's always nice to see an answer that says you can't do this, because you can just admit that you don't know how to do it and move on. But that's not the case here, because you guys now know how to work through this problem. Yeah, we're just gonna Remember to make a free body diagram. Use our understanding of forces, and always remember Newton's third law. It will come in handy, I promise. Thanks for watching. Let me know if you have any comments, questions, concerns, and check back in for video number 9.